This all-in-one vignette considers the use of distributed community-level technologies using renewable resources to meet all utility needs. Renewable resources delivered through innovative distributed technologies provide utility services to communities which need to be self-sufficient because they are isolated from others, and this isolation is likely to lead to living underground or underwater in the scenario of severe climate change. The worst-case global warming scenario for 2100 is a 13 degrees centigrade global rise in temperature. The effect in London will be temperatures as hot as Cairo, whilst London itself would be submerged under 11 metres of water. The planet would be subject to external extremes of climate, such as strong winds or tides limiting mobility between communities to times of clement weather. Our traditional utility services would be submerged or damaged. Distribution networks as they are today would no longer exist. Integrated utility services based on technologies using renewable resources would be required for self-sufficient communities. The technologies exposed to the weather will need to be tolerant of weather extremes. Developed interiors of mountains are living examples of closed communities protected from external difficulties. Such hardened installations can survive even nuclear, chemical, or biological attack. An example is at Colorado Springs in the US, where the Cheyenne complex was established in 1966. Integrated heating, ventilation, and air conditioning systems remove airborne chemical, biological contaminants, and carbon filters remove odours from sealed air. Local energy sources will need to power these types of systems, and also to provide within complex transportation of vehicles, people, water, power, and telecommunications. These integrated heating, ventilation, and air conditioning systems are an example of all-in-one solutions, and with the addition of power generated from distributed sources, they are a viable, near-closed, self-sufficient system. Mines are another example of underground systems which can be converted for use as living and social areas. In Cooper Beedy, Australia, an opal mine resolves many problems of energy efficiency, noise shelter, and also shields the community from extreme temperatures. It highlights issues of flooding and lack of sunlight. Flooding needs integrated pumping technologies, but the transfer of sunlight deep underground needs innovation. For sea dwellers, various concepts have been proposed. The green float idea is one in which the system is carbon negative. Most inhabitants and services would be located in the 1 kilometre high city in the sky towers to take advantage of lower temperatures. Small cells of green float can be connected to form modules which form units, which can be the size of cities accommodating 1 million people. Technologies capture the external renewable resources and use them to provide utility services. Intermittency would constrain lifestyles, and so storage of water and power is an essential technology. Technology for telemetry and for monitoring and prevention would form an essential part of the utility system. The all-in-one concept would reduce the number of transformations needed. Power from water pressure could create lighting even deep underwater. Warm water heated on the surface could be piped, avoiding the need for boilers. Rainwater would be treated for consumption using chemical technologies. Vegetation grown on the green float would capture sunlight but be protected from weather conditions. This would provide food, but the extent to which large carnivores might exist is doubtful. Vitamin D from the sun would need piping within enclosed dwellings, and technologies preventing the spread of toxins in utility services would become very important. The need for economic and production systems, in particular, for invention using limited resources and for recycling waste, will also create demands upon utility systems. The all-in-one question is addressed in this vignette through the notion of self-sustaining integrated communities. The use of technologies which minimise transformations and address the intermittency and spread of natural resource availability will be critical to provide sustainability.